guys, so today is March 27th and I originally recorded this video, but I wasn't able to do it. So I had to read the solution and maybe just make a quick summary of what I learned. I've only read the approach. Haven't tried coding it myself though, so maybe that would be cool to try. But I guess to explain this question, we're given this like 2D grid. And then yeah, we're only given like one like this 2D grid, sorry. And then we're also given like these queries. So um at each query, we always start at the top left of the grid. They want us to return how many values um that are strictly less than this 5. So if we look over here, we see 1, 2, 3, 2, and 3 are all less than 5, right? This one is less than 5, but it's not like connected to any of the previous results. So they want to make sure that they're all reachable. Like for example, for 8, we see 1, 2, 3, 2, 5, 3, 5, 1. Those are all less than. So they want us to count the number, right? So 1, 2, 3, 4, 5, 6, 7, 8. So this would be 8. And then this would be 1, 2, 3, 4, 5, 5. Um, so when I originally submitted, I just did the brute force because I honestly didn't really have an approach. So I'm like, I might as well just try the brute force and maybe it'll give me an idea of how to solve the problem. And what that brute force was is just looping the queries. And then every time we loop the query, we just run like BFS, right? And that was way too slow. That was ended up being O of k, which is the number of queries, right? Because we have to loop through the queries. And every single time we loop through the queries, we're looping through the m by n grid, right? So it's k times m times n, which just gave time limit exceeded. Oh, sorry. My mic was not in the right spot. Hopefully you guys could hear that. But the approach that I read, and I want to try this out, is kind of using like a heap or priority queue, using a priority queue plus maybe like BFS. And with this, we could leverage sorting to help us out. So these queries, there's nothing special about them. Why don't we sort them so that we're only processing the smallest query first, then larger, 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 and then we could just keep adding to our result so that we don't have to do unnecessary work. That being said, we also want to make sure that our like queue that we hold, like you could kind of imagine, let's just say for 5, it has a bunch of potential neighbors, right? Like all of these are the potential neighbors. Um, but we don't know which one to process first. We only want to process like the smallest ones at a time. So that's where the priority queue is good. Um, we will only process like the 2 before processing cell 3. Um, Stuff like that. Anyways, let's start. So, yeah. So like I said, the solution said to sort the queries. So definitely need to sort the queries. Before all of this, I always like setting m and n, m being the length of the grid, n being the length of the grid at 0. We do want a min heap that is going to keep track of a couple things. It's going to keep track of the grid at ij as well as the indexes I and j, right? So originally this grid is going to have grid at 0, 0, 0, 0. Which, sorry, I guess I could just do this. And then we just need to process the queries. So for Q in queries, and then we just need to make sure like Q is in increasing order, right? That's a good thing to note. And then we just kind of run our BFS. But I guess before that, definitely need some sort of result that we're just going to be like processing, like adding to our result right here. Then we could just return the result. And the result is the number of points. Yeah, I'm not so sure how we're gonna deal with the points, but we'll see. So we want the smallest thing from the min heap, right? So wait. Min heap in Python top of the heap. It's 0 is the top, right? So min heap at 0 will give us this one. 0, which is the value, while the smallest thing in the grid is less than the Q for that query, then we know that we can do the points, right? But we have to make sure that there's stuff in the min heap. So while min heap and min heap 0, 0 less than Q, I guess this is cur points is 0. Points is 0. After this, we just do res dot append points plus cur points. Oh wait, points plus equal to cur points. Then we just append the points. While the min heap has stuff and the min heap less than equal to 0, let's go ahead and get the pop from the min heap. So we'll do this. ij equals min heap q heap pop min heap. When am I upping my points? I think right here, cur points plus equals to 1, because we know that it's less than the q. Then we could check the neighbors, but we don't want to check something that's already been added, right? So I would need a boolean like used false times n for this in range m, just an m by n boolean array to track if we used it. So since we used it, I guess we could do used ij is equal to true, right? Because we used it. Now we need to check the neighbors. For I, jj in all four directions is what I'm doing right here. New I, new j, I plus I, j plus jj. We just need to make sure that it's in bounds with the grid. If 0 less than equal to new I less than m and 0 less than equal to new j less than n and not use new I, new j. Make sure it hasn't been used. Then we could go ahead and add it to the min heap, right? Add grid at new I, new j to the min heap. And then we don't have to do all the like checking to see if it's less than, because we just do it out here. So heap q, heap push into the min heap, new I, new j. Oh, no. Not just new I, new j. We also need to push, this is the most important part, the grid at new I, new j, because that is what's going to be sorting the min heap. We always want it by value. And then we always want to process the smallest one first. So yeah, let me submit this. I don't know, am I missing something else? Is that it? Closing parentheses does not match. Oh yeah. Right there, that's the grid. And then we have the new I, new j, pushing that into the min heap. Let me run this. So that worked. That did not work. And then also, I had a wrong answer earlier. Let me use that test case. Okay. Okay, this is wrong. But also, I sorted the queries, which I should not have done. Or I should have done that, but are the queries unique? Okay, because when I'm processing is I'm doing two. I'm doing the 2 one first, and then 5. Which is there. And then 11 is the 6. Or what? Wait, print the queue and the cur point so that I know what I'm doing. 2, we're getting 1. 5, we're getting 4. But 5 should be 5, like this. And then for 6, why are we doing 6? Let me see. A little bit confused about that. Yeah, those queries need to we need to maintain the original order like what they said. So maybe I'll copy that. Sorted queries is equal to we want to sort by value and then just maintain the index for index val and enumerate the queries. And then we just sort that, right? Sorted. Okay, and then maybe I'm doing the visited wrong. We already have used right there. Used at 0, 0 is true. And not used. And then heap to the thing. And then say used at new I new j is true. Query value and query index. Okay, so instead of appending to the result, we just know that what the size is. It's just going to be the size of the queries. K is the length of the queries. My result is just originally going to be 0 times K, right? For K, for the that current query, and it has an index, right? That we're just going to be leveraging here. The result at that index is equal to the points. But let me see, I'm still not doing something right. So while it's not empty, which is good, I do that here, and min heap 0, 0 less than the query, yeah. Then get the cell value, current row, current column is just heap.get. Okay, that's fine. Increment the total points. Yeah, I don't. Why am I keeping current points and then adding it to points in the end? It makes sense that we're just doing points. Just do this, and then update the current points. Yeah, that's what I'm doing. Explore all 4 possible directions. I do that here. Check if the new cell is within bounds. Okay, I do that. And it's not visited. I do that as well. Then I'm adding it to the heap. Okay, let me see if this worked. Sorted queries. This just needs to be points, but it doesn't matter. I'm just gonna delete this for now. Interesting. Wait, so it was bad when this is something about BFS that I have a little doubt on is I don't get why I have to put used at 0, 0 right there. And then when I visit the new one, I also put used to true. Why can't I just do this? And then whenever I like pop the value, why can't I just do used at ij is equal to true? Huh. Like I don't get that. Maybe that's just like my lack of understanding of BFS. But I mean whenever I do BFS, I'm used to putting it right here. Like in the very beginning, we always put like the first thing in, set it to true. And then whenever we look at a neighbor and we add it, we always do this as well. But I don't really understand why. I'll have to dive deeper into that. But let me submit this. Okay, there we go. Um, yeah, there's a lot to learn for this one. It's cool, I guess. Um, I mean, this problem, it's like how like what there's some properties of sorting. Like once we sort an array, obviously like we're guaranteed that it's sorted, so like every element after it is always going to be strictly larger. And then we know that if that's how we process the queue, or this like sort, like if we sort the queries and process it the smallest query at a time, we know that like our points will just keep expanding. And then we just want to make sure that when we run the BFS, we're not just running it in like usually we just put it in like a double-ended queue, right? But in this case, we can put um, these cells aren't treated the same. They're not just like in a random queue or whatever. They're they're put in a very specific order, or they're processed in a very specific order, where we always want to process the smallest cell first out of all of the neighbors, ensuring that we don't like skip through something. But the actual like code of like this is just like BFS. This is easy. But I guess kind of like realizing certain things, like all like the setup and just like realizing things is what makes it hard, I guess. But it's definitely doable. I just couldn't do it today. But yeah, that's it. Time and space. So sorting the queries is um, k log k. Plus, we're running it k times. Every time we do just BFS is just MN, right? Like this whole thing will take MN, MN. Oh, but when we're in MN, we're pushing into the heap, which I think takes log. What's our heap? Log MN. Let me see. So I think this is the time. Might be wrong though. K log K, NM log NM. I don't know why they didn't plus the K. Maybe it's like not significant. But yeah. Okay, that was cool. So that's the time complexity. Space is n times n because we're keeping track of the used thing. And then And then K, I guess, because we needed to sort it. Yeah. Anyways, hope you guys enjoyed the video, and thanks for watching.